So what we've got now is all these sections marked true, false, true, false, true, false. We are going to get rid of all of the code for each true and false, except for the internal contents that are true and false. Okay, so this is going to be a little on the complicated side. I'm going to need and condition where, so if it's logical, then we can go ahead and consider deleting this content. Now, the and is going to be anded with various conditions, yours. We can delete it if the end3 is false, or if it is an if statement, or if it is a close statement, or if it is a else statement. Closing of the end, we then say remove. Otherwise, we hear nothing. Of course, it will give an error. Probably because of the comma. Thankfully, just because of the comma. And why did that not include this? N3 has to be logical. Oh, N3 does not have to be a quote false, it has to be false. So now that should, in theory, have worked exactly the way we want. Anything that is a false block, we get rid of it and the if surrounding it. Anything that is a true block, keep the material that we need to evaluate. We remove the false if statement, and the else, we keep the content from within the else, and we get rid of that. Okay, so let's now carry this through the rest of the... These are only the removal, which means we wouldn't have gone overboard. For an example, this is the first if that we had to exclude. This would probably right here be the close that closes the if. Actually, maybe not. It's probably nested. I have to look at the original. Maybe that's a good thing just to double check. That's right. That was the if, nested if loop. It's actually part of its code, and we are just discarding all of the obfuscated trash lines inside of it, and we're not worrying about the rest of it. So we're only identifying the stuff to remove. We might have missed a few things to remove, but unlikely we have accidentally removed too many things. If O says to remove, let's blank it out. Otherwise, let's see the code. And that is a lot of lines blanked out. Still a whole lot to go. But let's just see now. Copying this, I'm going to go and make a new dif. And we'll just simply save it as is. No errors. So, yay. Okay, which is good because now it means we can reformat, push out all that empty space. And look at that, we're down to 602 lines now. So right now I'm going to take a moment to clean up some files. This tool managed to reformat it for us based on the actual spacing as well. So we won't have a whole bunch of indented extra indents that we had to worry about. So this has been all lined up with the same right coding. I'm going to copy it from here instead. Also made this a little bit bigger. What I'm going to focus on noting here is that this system is a series of functions. Everything is a function. The only code that is in the main scope is this, f, which calls function f. Now the thing is, anytime you have a function with a variable declaration inside of it, that means we're using it as a local variable. So I'm going to get rid of a bunch of these things by noting that if they're declared here and they're not used within this function, then I can get rid of them. Oh, you define text within the cell, and that should be a B1. Okay, now I'm just going to use a little bit of additional formatting here to simplify visually. Okay, what cell am I on? 556, so I have to do it this way. It's based on wherever your cell selector is. I figured that one out the hard way. Okay, so that is a lot of variable declarations, a huge number. So there's no way the system uses that many just by keeping a list here of all the ones that I need to keep. And then we'll just delete the ones. Okay, now this one uses a variable from it. That will stay. And this one does not get used. This one uses the variables from above, so we keep it. JAC is not used, neither is that. Okay, we go up to here. Easier to work from the back up because obviously anything declared here only can be used. Don't see that being used, nor that. Now, these are actually, variables are just declared as constants. That could be the trick. Any variables that are declared as a constant, the empty strings, you gotta watch out for those. And Boolean, we're not using this. And if I accidentally do delete something that was needed, it'll be easy to fish it back out later because we'll see the error within Eclipse. Anyways, I'm going to stop the video here now for a moment. So that only took a few minutes to go through those and just remove a lot of them. It was very obvious. Basically, anytime a variable was declared as a constant, it was pretty much garbage. A few instances where a variable was declared as some other variable, that one was very easy to keep. And then a few instances where they were set to null strings or zeros or new arrays, and I just kind of kept them. They won't be in the way right now. We'll clean up later if they're not useful. Something did kind of dawn on me as I was almost finished. In fact, probably working from the bottom, I was about here when I realized it. I could have used those if blocks to mark the variables that were declared for each of those ifs. So those cases where we had a variable that was set to 0 and then did the math of the sign of it, I could have marked that variable declaration as used in this discardable if state. Let's discard it as well. But I think it would have probably taken me just as much time to making the spreadsheet work for that thing as it did. Now, if the file was a lot larger, then I would have probably stopped and gone back a step and redid that. So now I've got a list of basically everything that's still a 1. I want to keep that line of code. Entire document. And crossing fingers, we will go over here, make a new file. Vard, paste it in there, hit the save button, and there are no errors. That's amazing. We are now down to 334 lines, so that chopped it almost in half. Still a lot of garbage here to get through. Now, there was something that I did also notice as I went through, and that is they have an awful lot of these functions functions that will return a mathematical parameter back, and they're not used. I think that these functions are just the trash part. So let me now take this whole code just quickly buzz through looking for any of these functions, and I'm going to blindly delete them. I'm not even going to check. My gut tells me that you're just padding, and it's a math function. I mean, they could very well be returning sign of something just to get a 0 or a 1 in certain cases to start a loop or something, but we will see that if the system shows an error because of a missing variable. Don't expect that. And I could have actually used the same logic as I did for all those if statements. My condition for the puzzle challenge to myself was to come up with a way to identify those if blocks, get them to self-evaluate, get them to remove themselves out of the code. For this part, I think this is pretty straightforward. Okay, so in theory now, there's no mistakes. Just like there was in theory last time, no mistakes. That worked in our favor. Okay, so now, again, in theory, the math. Save button, scan, no errors, got it right. Okay, so now with all that space squished out, what do we get? 218 lines. That's still a lot of garbage. There's still a lot of constant assignment. So I'm betting that that's going to be the next thing just to quickly double check for. Still a lot of noise to look at on the screen at one time and say, oh, these are the lines that I need. And these are the lines that I don't need, because it's just too much garbage to go from far up and say, does this variable, exist in this method? This is going to be easier to do in Notepad. Because Notepad has a nice little trick. When I highlight something, it will show the other uses of it. These ones where it may seem like those. Pretty much tells us which lines we need to keep. Okay, so I'm just going to work from the bottom and manually check for these assignment operations. That actually took virtually no time whatsoever. Again, most of it was just simply garbage to constants. We are now down to 117 lines. Human readable now at this point. We have a try and a catch. This, they're not doing anything with it. We get rid of that whole try and catch part. And down here again, same thing, another try and a catch. And this catch is nothing. Try is around a whole loop. Again, nothing done with it. Let's just delete that whole string. Realistically, there might be code in here that actually requires being wrapped in a try and catch, but I'm not actually going to be running this code to get the feel for it. The idea is, what is this thing doing? Not actually, let's see it running and do this thing. I'm going to try figuring this out from the code itself. 107 lines. I noticed just after stopping the camera that I had accidentally deleted this final line from the code. Easiest spot because we're returning a variable that I accidentally erased. Easier to find one line that's missing than having to deal with the, what was it, 500 lines that didn't belong there. I'm not going to waste time trying to reverse engineer what these procedures are. I can tell at this point, I know that these things are being used to basically convert this junk into probably a string. And in fact, this is a string because this is a string operation. So this will be a string here. Splitting means that it's probably going to have a whole bunch of comma delimited results in there. And then we're going to break this up into an array, and we're going to loop through the array and do something for every single one of them. So chances are web page links or addresses or something, and it's going to tell us to try to download a virus from these 10 sites or something. What I'm going to do is come up with a way to use this procedure, use all the code here, and let it decode these things for us into constants. The approach I'm thinking is like before, where we basically copied some code, had it spit it out in the HTML for us. Just for simplicity, I'm going to bring that function f to the very top, where I know that the main code is being run from. Now, instead of actually launching method f, I'm going to launch my own stuff. My own stuff is going to be to pull out all of these ANU functions. I'm going to jump the camera until I've done that. I'm just going to copy paste all these right up here. Okay, so there's all the lines with the new command in them. Okay. And then here, I'm going to change this variable name, because this is within code where something is basically assigning the value one string or the other string depending on whatever condition was being tested. Yep. Okay, then this we just have to do manually. I'm going to copy all that over to, I'm just going to paste it over to replace it. Okay, so I'm going to edit my document writing file here. This will import it automatically. FMN is not defined. That means I accidentally deleted a line somewhere. That is line 121.